It's not horrible. Let's make it a bit smaller.
All right. It's time to Xamarin.
It's always time to Xamarin. I'm just going to make my display a little bit easier to see here, hopefully. Let's see if we do 720p. All right, I think that's pretty good. Let's jump into it here, if this works for me. All right, it's time to Xamarin. Who's heard of Xamarin? Hopefully everybody, and that's why you're here. Yeah, I'm assuming the hands that didn't go up have just not put them up in time. So it's actually kind of cool to be here, and thanks for having me. Thanks for coming. A few years ago, I came out to one of the user group meetings here, and I've come to, I think, 2 on separate occasions. I live in Leamington, Ontario, so it's a little bit of a hike for me to get up here. I certainly would like to come more often. But I remember the first time I came, I wore a Xamarin shirt just shortly after Xamarin had been created out of, I don't know if anyone knows the history, but it used to be a Novell product called Monotouch, and then that kind of got dissolved, and then out of that, Xamarin was born. And so I wore the Xamarin shirt, hoping that maybe I could find someone else who had heard of Xamarin at the time. And there was one other person there that said, hey, I recognize that t-shirt. And so a few years later now, everyone's heard of Xamarin. So it's awesome to see how it's progressed and how people are started taking an interest in it now. Obviously, partially at least due to the fact that Xamarin's now part of Microsoft. So I'm Jonathan Dick. I am actually now a senior software engineer with Microsoft. So that was an interesting progression in my career for me. I didn't necessarily think that we would actually get bought by Microsoft, even though everyone seemed to think that's what should happen. So we want to talk a little bit about it today. But before I jump into it, I want to mention Rob Gibbons, you probably, I'm sure all know, is hosting a Xamarin Dev Days. I'll be helping with him, as well as one of our other colleagues, and maybe more people too, I'm not sure. Well, that went too fast. Let's go back. It's happening October 1st. It's happening here, I believe. And there will be some sessions, there will be some lunch provided, of course, some hands-on. If you hit that URL or bug one of us after or look on Xamarin's site, you'll be able to get information about the event pretty easily. Sorry, I had this slide timed and I copied and pasted it over. The other thing I want to quick mention is I have a podcast, a little shameless plug for myself, with my friend Greg Shackles. We talk about all things mobile, mostly related to .NET and Xamarin. So go ahead and check that out at gonemobile.io. And now it's time to start talking about Xamarin and building native apps. What does a native app mean to everyone? What does that word mean to you guys as developers and as users? Anyone? Anyone want to throw out a definition of what native would be? Runs on the hardware. Not in WebView, yeah. Anyone else? All right, I'll jump into what we as Xamarin think that building native apps mean. And this is what we think sets ourselves apart from other cross-platform development solutions. So there's 3 major things that we like to talk about. One of them is a native user interface. So that's really important to us, that we can create apps that give users the experience that they would expect on the platform that they're running on. I don't know if you've ever downloaded an app. How many are you Android users here? I'm like a die-hard Android user. So that's me, and I know I've often downloaded apps, especially like earlier on years ago, that when you open them up, they actually mimic like an iPhone user interface. And so what's going on? This isn't how my phone is supposed to look. So native apps to us mean that we're having actual native user interface elements so that it performs like you would expect. Another big thing is full SDK access, full API access for you as a developer to all of the things on a given platform. So any special feature that iOS has, you should be able to access from your own application. That's part of what native means to us. And finally, performance. And this is maybe one where a lot of people think of native first, right? You want to have an app that performs really well, that's really fast, that doesn't feel bogged down. How many people have downloaded an app that you could clearly tell was a web view wrapper of some kind, or maybe just it didn't feel quite right, it wasn't fast? Anybody get those apps from time to time? I think they're going away because more and more people are going native, but that's really important to us. We need things to be fast and fluid. And when we talk about building native apps, or apps in general, there's a few different approaches that we're seeing out there. And again, this is something that we think we do differently and we do in a better way for developers. So the traditional approach is this siloed approach where you actually have an Objective-C code base for iOS, you have a Java code base for Android, and then if you're doing Windows or Windows Phone, maybe you have some C# code bases as well. So the disadvantage here, obviously, is there's not really any room for shared code. Unless you're doing shared code down in like the C or C++ layer, which I don't know about you, but that's not for me. There's really no opportunity to share all of that between each platform. And often you'll see companies with different teams for each code base too. So you'll have your Android team, your iOS team, and your Windows team. And what I've seen a lot is that iOS gets babied, and it's always like the golden child. It's the first platform to get the new features, the new interesting UI, all of that kind of stuff. And then maybe the Android team lags behind a little bit and doesn't implement the same features, or maybe it's just slower to adopt them. So with this siloed approach, it's really difficult to achieve parity, feature-wise, performance-wise, and just a good user experience between all the different platforms in your app. Then we also need to talk about the elephant in the room, which is, write once, run anywhere. This is the holy grail of development, right? Of cross-platform development, is that I can write code once and I just run it everywhere. Well, if you ever did any Java programming with any of the UI frameworks on Java, you probably have admitted that this is just something that isn't quite feasible. You're not going to get away with writing a really good app that you write once and run everywhere. And we could talk a long time about my thoughts on hybrid web view apps and everything. And there may be a time and a place for some of that. And you can certainly do some of that within your Xamarin app too, if that's going to make sense for you from a business case or from just a migration case to a native app. But generally, we don't think that this is achievable. So instead, we like to talk about our approach, which is sharing a bunch of your code, as much of your code as you can, because certainly there's code that all of your apps are going to need to use. There's things that it's going to need to do, like contact a web service, save information to a database, doing a bunch of these kinds of things that, yeah, we can share that code. It's all C# code. You can put it in one spot and use it in all of your different apps. But then you see that top sliver up there where we're talking about doing UI-specific code for each platform still. So this gives us the best of both worlds of that, write once, run everywhere, which is kind of not really attainable for a good app, but not also having to go to that siloed development approach where you can combine the two. And the other nice thing is that the platform-specific code with Xamarin, you're still able to use C# with that. You can still, write your code that uses all those UI APIs and just cross-platform specific, or not cross-platform, but platform-specific APIs from C#. So that's what we let you do. This extends farther yet because I'm sure everyone here has done C# development that is, not mobile. So you get to use those same skills that you've already learned writing server backends, stuff in Azure, stuff maybe on Linux on Mono, maybe on Windows, wherever you've got it. The C# code is something that you can use anywhere now. Now that we've added mobile to the picture. And it's not just mobile, I won't talk too much about it, but you can write C# for Xbox One, you can write it for, I think PlayStation Vita has support. We've got pretty much anywhere that Miguel decides that he wants code to run, code will be running in C#. So C# is a great skill to have, and we're just extending that and leveraging that. Now, some more reasons why Xamarin is the choice for writing C# mobile apps. There actually is another option out there. I think they still exist to write C#. Well, it's kind of like C#. It looks like it, but it isn't really. But Xamarin is now part of Visual Studio. So how many people use Visual Studio on a daily basis? Lots of people. I actually am starting to now more. I got myself used to Xamarin Studio on the Mac, and we'll show you that a little bit too. But that was always one of the hard things to talk about before we were acquired by Microsoft, was that everyone kind of, we would pitch all of this idea of writing mobile apps in C#, and they'd say, well, that's great, but I can't afford to work with it in Visual Studio. And the way our licensing worked was basically, like, the cheapest license was, you could use Xamarin Studio, which, I love, a lot of people love, but I understand when people are comfortable in Visual Studio and want to use it there, which was a lot more cost prohibitive. So now it's really awesome to be able to say, yeah, you've got Visual Studio, it works there, it works in the Community Edition as well. So you really have no excuse not to start trying to build mobile apps in C#. We've also open sourced a ton of our code. Again, this was something that we couldn't really do until we were part of Microsoft. So if you go to open.xamarin.com, there's a long page of listings of open source repositories and all of our different stuff. And to highlight a few, we did our iOS, our Mac, our Android implementations, Xamarin.forms. Who's heard of Xamarin.forms? Good number as well. We'll talk more about that yet too. That's all open source. And then near and dear to my heart are some bindings and plugins. I actually work on the components team in Xamarin. So I do a lot of the integrations with like Google Play services on Android, Android support libraries, pretty much any native library that you can use in Xamarin I've probably heard of, or maybe I've touched some of them that have been released by Xamarin. So we're open sourcing a lot of those. Pretty much all of our code is going open. So, worst case scenario, you can go spelunk through the code and figure out how it works yourself. And then why C#? I'm not going to spend much time on this because I have a room full of .NET developers, I think. Sometimes I do spend a little bit more time, but it's worth highlighting some of the cool parts of it. This is going to be hard to see. Don't worry about line by line, but these are two code examples of doing the exact same thing, one in Objective-C and one in C#. And it always amazes me how well C# works for the Objective-C, the iOS APIs. Like, just the way that things translate, they're really elegant. It really makes writing apps a pleasure with C#. And I did a little bit of Objective-C development very early on, before MonoTouch existed. And, it's C# is just, it's leagues ahead. It's so much more fun to write with. So, you can use C#, you can use F# as well. We do support that. So if you're a Swift fan and you're looking for the .NET counterpart, well, there's F# for you. The other thing that we do with the C# side of things in Xamarin is we make APIs much more friendly for you as a .NET developer. So in this Objective-C sample, where they're asking for a callback to be passed in for the completion, so that's a typical pattern that we would use. Well, in that callback, maybe you want to do something with the UI thread. They don't show it in here, but you have to start worrying about things like, what thread am I on in the callback? Do I need to go back over to the UI thread to do the work I want to do? And in Xamarin, we're doing a lot of work at making things asynchronous, so we can use async and await patterns on them. So here's a good example of it where instead of having to pass in our callback and maybe pass in a delegate like we were just shown, we can actually await the call. And we know that the next line of code is returning us to the right threading context that we were on before. At least we know which threading context we're in. And if we were on the UI thread, we don't have to do anything more to be on it afterwards. So how does Xamarin work? Well, we're all familiar with the base class libraries, I think, all the system dot whatever. These are things that we've come to know and love on all the different platforms that we've worked on. Windows, maybe it's the Windows Server, maybe Windows Phone. And in the case of the Windows APIs, this is a common thing that we'll see. We'll see that base class set of libraries that we can use, and then we'll see some platform-specific APIs to access things that are only relevant for Windows Phone in this case. And so Xamarin does basically the exact same thing. So for iOS, we've got access to all of those base class libraries, but we also give you access to all of the the platform-specific APIs. So in iOS, we've got Core Graphics, which is a big one, UIKit, MapKit. These are just some examples. Anything that you can do on iOS in Objective-C, you can do with Xamarin and C#. Android, again, the same thing, the core base class libraries, and then all the Android-specific stuff. So again, anything you can do in Objective-C, Swift, or Java, we can do from C#, which is really, really nice. Now, getting into some of the performance parts of Xamarin, early on, Apple decided that, well, if you wanted to make an app and submit it to their store, you actually can't use just-in-time compilation in your app. It's forbidden. They won't approve your apps on the store. So back before Xamarin days, Novell, some of the guys at Novell figured out that, hey, why not just do an ahead-of-time compilation of our C# apps, and then it's just a native binary that we can submit to the App Store to work with iPhones and eventually iPads. We already know the target hardware that we're going to be hitting, so it's pretty trivial. Well, I say it's pretty trivial. The runtime team guys probably wouldn't like that, but we're able to ahead of time compile, so you get this native app that is submittable to the store. It's fast. Sometimes it's actually faster to do some of the things in C# and to invoke some of the Objective-C type selectors than it is from Objective-C itself. So there's a lot of questions always that we get about, well, is there any overhead to this? And there is definitely some overhead. I'm not going to try and hide that completely. But I think the places where you're actually faster help win back that loss of overhead, and the overhead has been getting less and less and less as we get faster devices and as our teams really go ahead and optimize all of the implementations. So most of the time now, like if you're developing the app properly and you had an Objective C version and C# version side by side, you wouldn't be able to tell the difference. Um, so Android works a little bit differently. We do have the luxury of using JIT on Android. So we do by default. You can ahead of time compile on Android as well. But I know that there's been some research done by our teams, and it's not always necessarily faster to ahead of time compile. There's a lot of different factors that go into performance measuring and everything. But rest assured, things are really quick on Android as well. So, I mean, native performance, like I said, that's one of the key pillars for us. That's one of the most important things. So there's been, countless hours spent on improving that, and it's at a state where it's awesome. And a while ago, before I joined Xamarin, they converted Android. I forget which version. They converted it all to C# from Java, and they ran it, and they ran a bunch of tests on the Java, and C# version. And there was a lot of cases where C# was a lot faster. And I think Dalvik, that was before the Dalvik runtime on Android, which is their implementation of their Java runtime. Before that was made, it was maybe a little bit faster than it is now, but Mono is a very well-established runtime, and so it works really well on mobile devices. So I can't harp enough on performance. It's often an issue that people are worried about for no good reason. So start using it, and you can make your own judgments. But I don't think you're going to have problems with performance. So sharing code, that's one of the great things about Xamarin, right? So we can share code with portable class libraries. Who's using portable class libraries at all? A few people. So the idea of portable class libraries is that you can have one assembly that targets a whole bunch of different platforms. You basically pick the platforms that you want to support, and you end up with this merged set of coding contracts of which APIs are available to you to use. And then you can put all of your code into one portable class library to be used in your iOS project, in your Android project, in your Windows Phone project, etc. So that's there. That's been supported for a while. We do have this new thing called .NET Standard. Everyone heard of that? That's the new awesomeness that's coming out. Yeah. So we're moving to that. We support that in Xamarin Studio to some extent, and in Visual Studio it's quite well supported. So that's eventually where you're going to go with your shared code instead of portable class libraries. But for now, we support both. And it wouldn't be really that useful if we couldn't pull in our favorite NuGet packages into our apps either. So there's hundreds, if not probably thousands of NuGet packages now that are supported in Xamarin iOS apps and Xamarin Android apps. There's a lot of stuff out there. So, things like Newtonsoft, JSON.NET, no problem. That'll work there. Microsoft, the system.net.htdp, no problem. Most code generally is going to work from NuGet packages now, or most major packages the authors have added support for Xamarin. So there is like a .NET framework or target framework moniker for the different Xamarin platforms like Xamarin iOS, Xamarin Android, etc. So if you look for NuGet packages in the description and stuff, usually they'll tell you that they support Xamarin. And if they don't, often you can go find the source code and try and compile it in, and it's usually not that onerous to change it to support it. But anymore, I don't really have problems. Most of the libraries that I would need to pull in are well supported. So that's a little bit of talking. And I don't want to spend that much time talking tonight. I'd rather show you how to code some Xamarin apps, so that's what we're going to do. I'm going to start in Visual Studio here. Let's just try switching my screen over. I don't know which one it is. Let's see. Yeah, it's that one. All right, that's going to be kind of big. So we're going to make an app. Let me go into Control Panel here and just change some display settings. We're going to make an app, and in honor of the Olympics, I want to make an app that shows some Olympic data. Oh, that's awesome. Never seen that one before. Let's just try this way. So I want to make an app. Anyone seen that before? That's fun. Well, let's dive into Visual Studio and see if it's possible to increase the code and everything so you can see it. It might be hard to see the Solution Explorer a bit, but I can do the coding window so it's a little bit better to see. So I want to make an app that shows medal counts. I want a list of all of the different countries, all of their medal counts, and I want to be able to see that quickly in my app. So let's do a new solution here. Let's close this guy first. So go File, New Solution, or New Project as it were. And if you've got Xamarin installed, there's a whole bunch of options here. Again, that I don't know if I have a zoom tool installed here right now, that you are able to leverage here in our C# column. We could search for them too. There's a section for iPhone, there's a section for Android, then there's a section for, we should have a cross-platform section here. And this is the one that we're going to be interested in today because I want to show you how to share code between apps. So what I'm going to choose, there's a bunch of different options here. We could make a Xamarin Forms app. We'll do that in a little bit. But first I want to show you where the grassroots of Xamarin is. And this is in actual native apps that are separate from each other, but going to be sharing some of the backend code. So I'm going to pick the native portable template here, this blank app native portable template. And there's actually another one. There's a native shared one. We do support shared projects. So you can have a shared project referenced in your iOS and Android apps. Generally, our advice is to use the portable class library. You run into some interesting edge cases with a shared project, and it just, PCLs work better, especially if you're pulling in a lot of different NuGet packages and things like that. So start with that one. You can explore shared projects later if you really are interested. But let's call this Olympic medals, and I'm just going to select that template and create my new solution. And this is going to create a solution for me with 4 different projects since I'm doing it in Visual Studio. It's going to make a portable class library project. Can I zoom in on that one at all? Does Visual Studio let me do that? It doesn't appear so. Can you guys see that at all? That's kind of hard, isn't it, in the back? I'll try and explain it as best as I can. So I've got a portable class library project here. I've got an Android project. I've got an iOS project. And I've got a Windows Phone project. I'm just going to remove this Windows Phone project. We're not going to or unload it. We're not going to work on that one right now because I want to show you the Xamarin stuff instead. So in our portable class library project is where we're going to put our main business logic. So we've got this class here. How's that for size? Do we need it a little bit bigger yet? That's good from the back? Okay, perfect. So I've got my shared project here, or not shared, my portable class library project, and this is where I'm going to add my logic for downloading some data to show the Olympic medal data. Now, I've got a NuGet package already created, and before I do that, though, I'm going to go into the project properties, and I'm going to show you, this is what a PCL looks like in the settings here. We've got the different target frameworks that we're actually targeting in this project, and I could go in here and change them and add, say, Silverlight 5 is one that's not selected here. Xamarin Android and Xamarin iOS are selected here already. So this is, whatever you pick is going to change which PCL stands for, portable class library, for which PCL profile you're targeting, and there's numbers associated with them. Now, I did want to play around with the new .NET Standard stuff, so the NuGet package I made actually targets .NET Standard 1.1, which if you look up the conversion is PCL profile 111. So I could change this to be PCL profile 111 and add that NuGet package in. But the other cool thing in Visual Studio is I can switch my project over to a .NET Standard project. So I'm going to do that instead because that will make it really easy to pull in my NuGet package if I use the same .NET Standard version. So I've got .NET Standard version 1.1 selected here, if you can't quite see that. So this project should be ready to go to pull in my NuGet packages. So let's go ahead and do that. And the one that I've got is the only one that seemed to hit a search result when I searched for Olympics. So I've got this Olympic data client. It's a silly little thing. I've got a little service on Azure that spits out some JSON with the most recent medal counts. So we're going to install this NuGet package. In the real world, hopefully you have a lot more interesting stuff to work with than just this. But that's what we're working with today. So I've got that installed. And you can see on the side here, it added a few things for me. But let's go into my code and let's actually start accessing that service. So let's call this class Olympic Data. Just make it a public static class. And let's do a public static async task of, we'll figure out the type in a second. And we'll do get medals async. So the point here is to return our data in our shared layer that we can then go ahead and use in our specific apps. So if I start looking at the namespace of what I referenced, of the NuGet package I referenced here, I've got this Olympic data client namespace and a class in there. So if I create a new instance of this, new Olympic data client, I do need to give it a base URL. I just did this in case I ever needed to change the Azure instance site, but it's Rio Olympic data.azurewebsites.net. Please don't hammer that too hard. My free monthly credit will probably not like it. Did I write the Olympic data class? Yes, this is a NuGet package that I made specifically for tonight, just to demo some stuff. It was actually really hard to find a good Olympic information feed. They're all not free, but I found a way. So I've got this client, and then I can just simply say, let's go client.getMedalsAsync. This is a method from the library that we just added via NuGet. And of course, we want to, well, we could await that, but since we're not doing anything, I'm not going to do anything with this data. I'm just going to return it as is. So let's actually get rid of the async modifier and just return the right task. Since this method actually is going to return a task of type medals response. So that class is coming from this NuGet package. Ooh. So let's do Olympic data client dot medals response, and we'll take a look at what that type actually includes in a second. So the point of this is to say, hey, look, we can do all of this code in a shared place, right? You're going to have much more interesting stuff. You might be connecting to web services. You might be doing database work. But this is where you would put that code. And the goal is to put as much of your code as you can here instead of in your app-specific projects. So I've got that created. Now let me come down to my Android project. So we've got some information. It's going to be a list of medals counts per country. So every item in our list is going to have a country, how many gold, how many silver, how many bronze, how many medals total. That's what we want to display on our list. So let's start with our Android app, since it seemed like there's a good amount of Android users, and I'm quite partial to it myself. So in this application, we've already got this project reference, this portable class library project reference in our app. The template did it for us. We've got a couple other things here. We've got an assets folder that is sort of an Android-specific concept of embedding different assets in your application. And then we've got an Android concept of a resources folder as well. And so we don't really try and hide this from you in Xamarin. If you're doing the UI for Android in the platform-specific project, we want to use the same Android app isms that Google does. We just want to expose it from C# because you get a lot of interesting things from using what they use. We actually use their tools to compile your resources for you. So the resources folder can contain a number of different folders. It's got drawable folders for different resolutions of images. So it's going to pick the right image based on what density of screen your device is when it's running. So we would put those all in there. It's got our icon. And then we've got this layout folder. And this is where we put our declarations for our actual UI layouts. And I've got this main.axml file here. So the project template created this for me. If I load it up here, it's going to open up this Android designer. So we have a full-on built-in Android designer. And I mentioned that we don't try and hide things from you, the Androidisms from you. This is actually going to spit out Android. You could copy paste this into Android Studio, the layout code that it generates. So by default here, I've got this little button. I could, add a whole bunch more stuff here. You can choose different ways that you want to view the preview of the layout, different device. So Nexus 7 is a bit bigger. I can say, what does it look like on a different version of Android? I can choose, so as that catches up, I can choose what a different theme would look like. So I can say, what's the device default light theme? Well, that looks a little bit better. Let's stick with that. I'm going to go back to the latest version of Android, though. So I've got this main layout file, and I'm going to get rid of this button. Just delete it off of there. And let's go to our toolbox here, and I want to add a list view because we want to show a list of data, right? So let's just search for our list view here. I can click and drag it onto the canvas, and it doesn't really look like it did much. There is a list view there, so let's go into our source code tab here just to make sure that we, it did what we're asking for. So I've got the source code open here, and this is what it looks like. This is what Android layout XML looks like. This is Google's format. We're not inventing anything new here. So we've got this linear layout, which is kind of like a stack layout, and we've got our list view in here that I created. The width and height are set to match the parent, so that the linear layout, which is set to fill the parent, so it'll be the whole screen. And then we've got our identifier here, this list view 1 ID. I'm just going to rename it to list view. It's a little bit cleaner. And one of the other cool things about the designer is you can't really see what stuff's going to look like here. But if we go into our properties pane, we have a whole bunch of stuff we can set. We can set the padding on the layout. We can set background colors, all that kind of stuff. But we have this section here called design time. And inside this section, we can say, well, what at design time, we want to preview what our list item layout is going to look like. So if I go to this tools list item layout and go to the browse button or the more button, it's going to give me a list of all of the layouts that are actually in my project right now. So you can see there's only one. It's this main layout. So we don't really want to use that for every list item because that's list view inception. But I can also go over to these framework resources. And this is a set of layouts that Android actually has built into Android itself that we can borrow. So there's one called Simple List Item 2, which has a text view on the top and a text view on the bottom for us to show a title and a subtitle. So rather than creating my own layout, which I definitely could go add another layout file and put my own text views on it, put an image on it, do whatever I want, and I could use that layout in here as well. I'm just going to use the built-in Android one for now. So as soon as I do that, you can see, did I select the right one? I'm not sure. It should show 2 lines of text. I might have selected the simple list item 1. In any case, you can see a preview of what that layout is going to look like on the list view. It's not actually going to do that in code. It's just a design time thing, but it's kind of handy to use. So I think our layout is actually good. We're going to go ahead and go to our main activity here. So this is another file that was created in the project template. Android has a concept of activities. An activity is like a screen, like a window, right? A view. And so our main activity here has had the button on it before, so the code for it just incremented a counter every time you click the button. Kind of cute, but not really that necessary. So I'm going to get rid of that boilerplate code. And what I'm left with is an onCreate method here. So this happens once per life cycle of the activity. Every time the activity is created, our onCreate will be called. And then you can see this set content view here. So this set content view is actually asking us for a layout resource identifier. And that identifier is derived from the name of the layout file that we're using, so main in this case. So our tooling is actually going ahead and compiling the resources using Android's tools when you make changes because they need to be made available to your code to specify. This is how Android does it. The concept of an activity is Android's concept. We're just letting you do it all from C#. So I've got my layout created. The next thing I need to do is actually figure out how to assign items to that list I added to that layout, right? So let's just make a field here, a list view. And since I've already set my layout, the content view, I can go ahead and find that list view from the activities view. So I can say this.find view by identifier, by ID, and I can pass the generic type argument list view, so I get a strongly typed result back. And then I need to pass another identifier. So you can see a theme here of working with these identifiers with resources. So this isn't a layout identifier. This is actually a resource ID. And so in this case, if I start typing, because this is where we got the other thing from, resource, you can see I've got drawables, I've got ID, I've got layout. So what I'm after is the identifier. And again, we've done that compilation in the background, so this my button, you know what, I should have a list view identifier. So it hasn't compiled for me properly in the background for some reason. But I should have a list view property here. Maybe I didn't save, well, maybe I didn't save that, or my main AXML file might have had an issue here. You know what, let's get rid of this designer thing I added in just to be sure that's not causing us problems. It should work fine. Let's try that again. So I should get a list view. We're just going to do that right now and hope that eventually the compiler catches up. So I need to assign that to my field, of course, and I've got a list view now. So the next thing you might try and do is say, well, list view dot add items. Well, I'm not used to Visual Studio. I apologize. I'll be much better in Xamarin Studio. So I would say maybe I could add items. No, there's nothing like that. Maybe there's an items property. No. But we do have this adapter property, and this adapter property is what we're going to use, and it expects an iListAdapter interface. So we need to create an implementation of that to tell the list view about our items that it needs to display. So let's go ahead and do that. Let's create a new class. Let's just call it metals adapter, and I could implement manually this iList view or iList adapter, but there's a lot of stuff that I'd have to do if I wanted to do that. I don't really like working that much, so don't tell anyone at Xamarin or Microsoft that, please. So I'm going to use this class called base adapter, which already implements the interface for me, and I can use a strongly typed argument to say what's the class type of the item that I'm displaying. And I didn't really show that yet, but in our NuGet package, if we go spelunking a little bit, actually first we need to add the NuGet package into this project as well. So let's do that. As soon as that finishes being added, I should be able to go to my Olympic data client. Oh, how about I accept some licenses first? Oh, the HDMI is working over that. Let's turn that down a bit. All right, so Olympic data client, anytime now. It's going. It's trying. You think that this Dell would be a little bit quicker? All right, Olympic data client dot. Well, I'm just going to type it out. The type that we're going to use is metal. So that's what we're going to want to actually implement our base adapter for. Let's make that a bit more clean. And we could go ahead and just use the refactoring here to implement the abstract class. And you'll see a bunch of different stuff that now we need to implement. We need to pass back the actual metal for a given list position. So that probably means we want to keep a list of metals, right? Let's just do this and we'll import that or add the using statement in a second. So let's make a new list of metals and add some using statements. Huh, didn't seem to want to add my Olympic data client that nicely for me. All right, let's truck on for a second. I'll figure that out after this part. All right, so we need to return from our list of metals the given position. That's easy. We need to return a count of how many items are in our adapter, so that's going to be the count of metals. Pretty easy. This get item ID, I mean, this is all Androidism stuff, and I don't really truly understand what they want by this, but I always just pass back the position that was given to me. And that seems to have served me well, so let's do that. And then finally, we need to implement this getView method. So we need to give Android, we need to give the adapter a view of how we want to represent the metal that we're talking about. And you can see here they give us the position again of which metal, so let's get the metal from the list first. And after that, we're ready to actually create a view and set up how we want this to look. Well, Android has this concept of recycling views in a list. It's kind of like, it's a virtual list, and probably, you know, there's some parallels on Windows. If I'm trying to remember way back to Windows Forms, I think you could even do it. So we've got this idea of a virtual list, and they pass in this convert view type parameter to this call. This may be null if we don't have any views that we can actually recycle, or it might be not null, and it means we can actually use that view to recycle it. So what happens is when you're scrolling through a list, as you know, you can only see maybe 8 or 10 or whatever items at a time. Once you scroll past a few of them, those will get thrown onto the recycle queue, and if the recycle queue is not empty when this get view is called, one of those recyclable views will be passed in. So what I usually like to do is say, make a variable for a view and say it can be convert view, or if that's null, I want to actually create a new instance of that view because we need to give it something. And the way that we do it on Android, long story short, is we need to inflate our layout file. We need to inflate our view. So there's actually this thing called layout inflator that we're going to use. And we need to create a new instance of our layout inflator, which we need to do by passing in a context. That leads us farther down the Android rabbit hole. So Android has this concept of contexts, and a context is, without getting too detailed, it can be an activity, it can be a service. Basically, usually you use one of those two as your context. So we need to give our layout inflator a context here. Now, our adapter has no concept of what that is. So we're going to actually have to assign a context to our adapter. This is one way to do it anyway. So I'm going to make a public property here that don't let me forget to fill it out when we go back up to the top. Otherwise, we'll run into some issues. So now that I've got a context, I can just pass that in, and my layout inflator has been created. Now that I have a layout inflator, I can say, let's inflate a layout. And again, I have to pass in a resource identifier. So in this case, it's not resource.layout.main. We didn't want to do that. We used the Android built-in one, right? And it doesn't show up under this resource.layout because it's actually part of the Android resource layout class. So if we look through our items here, we can find a simple list item 2, which is the layout that we want to use that contains those 2 text views that we want to display. We could have used our custom layout here again if we wanted to, but we're not going to this time. We can assign a parent view group, the one that's passed in for us, and then we have this option of whether or not we want to attach it to our view to the root. Again, not getting into technical details too much here, but choose false in this case, or you might have a little bit more hardship than you would like to experience. So that should create our view for us, and now we could simply return that view, but we really haven't done anything with that view yet. It's just going to be a blank view. So we want to find the text views that I was talking about inside that view. So just like we used earlier, we can ask our view for find a view, so a child view, by the identifier, and we want to use this time it's a type text view. Now I could show you the actual XML layout for that simple list item 2 file. I'm not going to do that, but it would look similar to what we just saw in that main layout. And I'll tell you that there's 2 text views in there, and one of the identifiers for one of those text views is not resource.id, it's android.resource.id because we're using the Android built-in stuff. It's text1. So that's the identifier that you would find if you looked at the source code for their built-in simple list item 2 XML file. So once I've got a reference to that actual text view, I can set the text. So why don't we just set it to the metal name, which is going to be a property that we'll see once I get the references working. That's going to be the country name. And I need to do the same thing here for text 2, which is going to be the subtitle. In this case, you know what? Let's get that reference working right now because it's much cooler to show the next part. Now, why is that not coming in for me? References, Olympic data client. Well, so that should be doing it. So in this metal type, we've got a few different properties you can see here. So let's go back. Does anyone see anything obvious that I'm missing here? Let's just. I don't. I was hoping that IntelliSense would fix it for me, but that's a good idea. Let's try it. Should be Olympic data client. That should do it for me. You know what? I'm in.
Is a mismatch between like the standard library, that standard, and what you're using?
That's possible, but it should. Yeah, it should be working. It was working before. Let's try that quick. Let's go back to this project. Remember, we converted this to a .NET standard. We can go back the other way. We can go to a portable class library one, and Visual Studio doesn't give you the option to see the actual profile number in the drop-down here when you choose which platforms you're working with. So I'm going to have to try and guess here. I think it's, is that 111? Anyone know off the top of their head which ones I'm going to want to use here? Probably not. That's my job. Sorry. Yeah, I do want to use Xamarin Android, but I want to keep that one referenced to my data client here. You know what? Let's cheat a little bit here. I don't know if this is going to give us more problems later, but let's actually just go in and browse to that assembly. Because this will be in our NuGet packages folder. Is that what I called it? Let's go packages, data client. Let's try that. Oh, I think it's already referenced. Let's remove it quickly and add it back in. Let's look at the output this time. Maybe that'll give us some more information. So it says that we added the reference all right. Main activity. activity. Maybe I just need to build this guy. It might actually let me cheat because we switch it back to a portable class library. Well, it helps too if I use actual code, right? Return metals.count. All right, that let us build. So I think I might have convinced it. I'm not sure that's going to bode well for us, but we can continue on for now. Okay, that's what you get for trying to use the new cool stuff, right? So instead of the metal name here, let's do some more new cool stuff. That never burned us before. Let's go, make a new string and say the gold count is metal dot gold count. The silver count is metal dot silver. And the bronze is metal dot bronze count. And that's good. So we'll see all the different counts of metals here. So now that we have that whole view filled out, we're returning it. That's going to set the view up for what we want to actually display for that metal. So let's scroll back up here a little bit. Now we want to actually create an instance of this adapter. So let's go metals adapter, and let's create a new instance here. And what did I tell you not to let me forget? The context. You guys almost let me forget. I won't forgive you. So remember I said a context can be an activity. So this works because we're inside an activity. So we're adding that to our metals adapter. And now that we have that created, we can finally say, the adapter is the adapter we just created. Now, we're missing a couple things here. Does anyone see anything wrong with our adapter and our list of metals? It's just a blank list. That's not going to do anything. So let's make it do something. Let's make a public async task method saying, let's just call it refresh async. And in here, I should be able to use my, how about I stop trying to take shortcuts? We should be able to use my Olympic data class, remember that static class we made in our shared portable class library, and get metals async. And that returns us this metals response object. So let's get a hold of that. Say response equals await. So using that fancy async await in our Xamarin Android code. And then we can say, let's make our metals equal to the responses, and let's just make sure it's not null. The response is metals property, which is just a list of metal. And if it is still null, because I don't trust my networking code here, let's do a new list of metal, so at least we won't totally crash it. So here's our refresh async call. That's going to actually update things for us. Now we could be tempted in this onCreate method to do it here. We could say, adapter.refresh async. This onCreate method only gets called once per the life cycle of the activity. I want always the latest metal counts up to date in my app when I open it. So if I go switch between apps and I come back to this app and the activity is still in memory, which is quite likely, very possible, and Android hasn't decided that it needed to clean it up, I want to actually have the metals update for me. So I can override another method here on resume, which is another part of the activity life cycle that Google has created. And this one will get called every time my activity comes back into view. So I can use that call right here to say adapter.refresh async. And because it's async, I do want to await it, which means I'm going to have to mark this async. And we're getting into that dangerous territory of marking a void method async. So that's fine because you can't change the signature of the method that you're overriding. But just remember that if you're doing something important after here, like spelling, that you might not make it there if your async method fails without doing some kind of nice, try-catch blocks around it, right? So whenever you're doing that kind of stuff in Xamarin, just be aware of when you're using async await, especially in overridden methods like this. So it's perfectly fine to do as long as you're being safe. So that should do it for us, but there's one more thing I want to add to this before we run it, and before I hook my phone up and actually show it to you. That is, we're already taking advantage of async await and not tying up the UI thread, right? That's really important. That's something that maybe I glossed over. But we're doing this refresh async instead of doing our network call on the UI thread in our resume call. So that's a good start, but it's still not really showing the user what's happening, right? When the list is being refreshed, the user has no idea what's going on. They just see, in this case, a blank window, and they might think that the app is actually stalled. That's not very good. So let's add a UI indicator of some kind that shows them that something's happening. Well, this is a good time for me to advertise our component store, which is something that I work on. In projects for Android and iOS, you'll see this new little entry called components. It's like NuGet packages. A lot of components are both on the component store and on NuGet. And really the time when you use the component store is when you're looking for new stuff that you don't really know what you're looking for, because it's a curated list of Xamarin specific packages that work with our apps. That they've been vetted, they've been tested. They have samples and they have getting started guides. So these are things that NuGet isn't very good at. NuGet's a great binary package manager, but it doesn't tell you how to use the packages. So if you're looking for something, I encourage you to check out the component store, even if you just look on the store and decide to go get a NuGet package for the same thing if it exists. And I apologize about my resolution here, but you basically end up with a, let's do it here, components.xamarin.com. You basically end up with a view into this where we have hundreds of components. I think we're over 600 now. So there's all sorts of different stuff that you can use. There's barcode scanners, Stripe. There's all sorts of UI libraries. The one that I'm going to look at in particular, I happen to make, is called AndHUD, and it basically lets you display a progress indicator. Really simple. So let's go ahead and add that to our app. So we would go into our similar view here that you probably can't see anything of, but I'm just going to go to the same component. I'm going to add it to my app. That's going to get downloaded. In some cases, it'll actually add NuGet packages to your project for you when you download a component, if that's how the component author chose to do it. So I've got this component here, and if I open it up, you'll see I've got some information. I've got a getting started guide here, so it's giving me some code of how I might display a really simple, how I might use this library. There's a samples tab. You could open up a sample solution to see how the author intended you to use it. So it's a good place to start. So I've copied that basic code of how to show a UI indicator, activity indicator, and I just need to import the using statement here. And so it's pretty simple. So I'm just calling this andhud_shared.show. If we look at the method signature, it wants a context. There's that pesky context again. Luckily, we're writing the code in our activity, so the context is this again. And then I'm just going to make a really simple loading message. I'm not going to deal with any other properties here. So that's all I need to do to show some progress indicators. And then to hide it after all is said and done, I want to just dismiss it. And again, I need to pass in an instance of a context. So that's going to give our user some feedback. So that was pretty easy to add something like that into our app, right? There's a whole ton of stuff out there like this that makes your life as a developer a lot easier. All right, so the next thing I'm going to do is actually go ahead and run this. I've got my Nexus 5X chosen here, so it's connected. I'm going to start compiling while I get the rest set up. The first time that you run it takes a little bit. And I'm going to run, has anyone heard of this great app called Visor? No. It's pretty cool. It lets you actually view devices that you've connected to your machine right on your screen and interact with them and everything, which is kind of nice. Really good for demoing stuff. So here's my phone. We're still waiting on the deployment of our app. Seems like it's compiling though, fingers crossed, knock on wood. And so what should happen here is we should see our app pop up and see a nice little loading indicator, and then our list of data should come down. So I'll give it a couple seconds here. And we're going to go over the same thing in iOS as well, and you'll start to see a lot of similarities in the way that you need to do things between Android and iOS. You certainly need to know a bit about each platform, and even if you'll see, like once we start using Xamarin Forms, you'll still need to know a little bit about each platform. And here's our loading indicator, just by the way. That's that 2 lines of code that we wrote. But once you've kind of established what the different UI idioms are for each platform, it's pretty simple to create apps for both platforms. Now, I didn't see a list of data. I may have missed something, or what I've found before is my web service needs to be kind of primed. The first call to it doesn't always work. So now that I remember, I put that call in the on resume, which isn't showing up for me still. Great. Yeah, I'm probably blowing something up here. Let's actually see what exception we might be getting. Oh, I can't do that here. Let's just set a breakpoint here just to see what's going on. It might be going back to the problem that I tricked it into referencing the DLL. So that would be fun. If that happens, I'm just going to copy and paste some code in and show you exactly what you shouldn't have to do. No, I think that's still going. Let's see if my actual web service is working here. That would be... That's working. All right. Well, that's kind of anticlimactic if you can't see. Oh, maybe I don't have network connectivity. That'd be a way easier way to diagnose this. No. All right. We'll get that working yet. But that's how you should be writing code to actually make your Xamarin Android app to show the list of metals. So, any questions about Android before we start moving on to iOS? Or I don't know if you guys will have what the format usually is for breaks for you guys, if you need to take a break, or any questions, anything. Pardon?
So you selected a simple view, something like that, with the refresh, so you can't target, it's not saying that.
The simple view? Oh, no, that was you're talking about in the layout file, I removed a property here. That was just a design time property, so it really doesn't have any bearing on the runtime. But yeah, thank you. That may have been a thing. Yeah, I don't see anything obvious. Rob's got his head down, so he probably isn't watching what I'm doing. No. List of metals should be going. Adapter. Assign the adapter. Pass it my context. Yeah, I'm not seeing anything obvious. Oh, yeah, I know what I did. I know what I did. Here we go. So I refreshed my metals list, but like this is an Android class. Just because I added items to this list doesn't mean the adapter actually knows that I did that. So I actually have to tell the adapter that, hey, my data set has changed. So we missed one call. So let's try this again. Should be faster to deploy this time. That really would make me much happier if we could actually see what we did. Anyone made any Android apps before? Yeah, a couple people. Did you guys use C# or Java? Java? Oh, I'm sorry. I haven't had to do that much in Java, although what I do for my day job, it makes me, necessitates me doing some Java sometimes just to kind of figure out why something might not be working, like if it's a C# problem or if it's a Java problem. And usually it's a Java problem, but I don't like it. I'd rather not have to code in Java. And Objective-C, well, I don't think anyone likes to code in that. Does anyone like Objective-C? Anyone like coding in Objective-C? Anyone like string by concatenating strings? No? To do, it's kind of a Objective-C developer joke. To do that, to do a string concatenation, you don't do string plus string in Objective-C. You write, the variable of your string name, and then you say string by concatenating string, and then you pass in the other string you want to concatenate. It's really great. So here we go. Finally, it worked. And I love doing stuff on this Windows machine because I can't do it on my Mac. I generally love my Mac, but like I can scroll on here just like that. So we got a lot of items, right? And the scrolling, like you'll see some lag on here because I'm showing you like a video stream of the screen, but it's really fast. Like this is native. This is as good as you'd get on an Android app. Not that it's a terribly complex application, but still. All right, so that's our Android app. And if there are no questions and nobody is telling me that we need to take a break, I'm moving on to iOS. Okay, questions?
Actually, do you have support for fragments?
Yeah, absolutely. Fragments are supported. I actually have the pain of doing the integration with all of the Android support libraries with Xamarin, so all of that stuff's supported.
Could you repeat that question?
Yeah, so he was asking if we had support for fragments. Fragments is it's kind of like a type of view. That's simplifying it in Android. It's an Android concept. It's not a Xamarin concept. So like you would use fragments inside of an activity. So we do support all of that. Yeah. Sorry, a couple. To split the source and designer. Like and you're talking of like having two different people working on that. Oh, I see. To actually see them both on the same screen. I don't know if Visual Studio supports it. I'm not sure. I don't. I think you might be able to like. No, yeah, I don't think you can actually. To be honest. What? Yeah, well, yeah, but is that gonna work for? Because the tabs are down here, right? I don't think you can do that. Can you? Yeah, I don't think that works, unfortunately. That'd be a good thing to request though, or some good feedback I can send back to. Um, there's a couple other hands I missed. So scroll back up in which the activity. So you want to see the metals adapter? Yeah, yes. I made an instance of the metals adapter, which implements that interface that the list.adapter property is expecting. So we could have done we could have made we could have not used base adapter like we did here. We could have used iList adapter instead. I don't know if that answers your question, if that helps. Yeah, so that's just kind of a cheating way of passing the context in. That's how I've always done it. There may be other ways to do it as well, or I'm sure there are. Any others before I move on to iOS? Cool. All right, so we had that solution. I hope I don't have to trick iOS into the same shenanigans, but this should be a little bit faster because we don't have to describe all the different stuff we're doing. One of the things I probably should do is add that reference, though. So let's do that right now. I'm just going to do it the same way to make sure that we trick it just as well. So we've got our shared code, our Olympic data client in here. And now there's a few things in the default project that for iOS that you'll see. We see a folder here, a special one called asset catalogs. So again, we're not hiding anything that iOS does for you. They have this concept of asset catalogs that is where you put all of your different images. For example, your app icons, you'll have all sorts of different resolutions for all the different versions of iOS and the different types of iOS devices because they're all different resolutions. Apple has kind of made a big mess of this in my opinion because look at all the different icon sizes that you need for your app pretty much. And then same with like your launch images, your splash screens and such, you can do that in the asset catalogs now. So that's an iOS thing. We start our app with this app delegate in iOS. We have a number of methods that get called for us when the app finishes launching that we can tap into when our app goes into the background, when our app goes back into the foreground. So that's how iOS does it. We're not hiding the API, we're just exposing it via C#. We've got these plist files here. This is another format that Apple uses. It's like a weird XML format that I don't understand because it doesn't really fit properly with XML. And for some reason, it's not showing everything here, but we have sort of these nice UIs to help you set up the right information in your plist files that Apple is actually expecting. So stuff like which asset catalog to use for your app icons. So your info plist is kind of like this special file of all the different parameters of your app. Then we have a storyboard file, and this is our main storyboard. So just like Android layout XML files, we have a designer for iOS stuff. Storyboards are an Apple format, and we've created a designer to do the same thing. Again, you could take the storyboard and go back to Xcode and use it there. And it'll take a little bit longer, one, because it's actually, hopefully my connection is still good here. It's going to actually be connecting over to my Mac, which brings up the point that some people ask about. You do need a Mac if you're going to do iOS development, even from Visual Studio. That's how we interpret Apple's developer agreement, and you generally don't want to be on Apple's bad side. So we've taken a pretty, I think, conservative approach there, and that's how we are interpreting it. So a lot of this stuff connects from your Windows machine to your Mac. That acts as your Mac build host. You don't necessarily need to do much on the Mac. You can do pretty much everything from Windows now, and we'll keep showing you that too. So here's our storyboard file. We've got one view controller in here. And our view controller is like our activity. It's like our window, our main view. And we could start dragging stuff over here. We could add other view controllers. I could add another one here. We could wire up the segues between the two. A segue is like your transition from one to another. That's Apple's terminology again. And we could go on and define our whole UI in here. But our UI is pretty simple. So I'm going to take my main view controller here. I'm going to get rid of the button that we had by default. Now I need to add some kind of list. So on iOS, our list, or concept of a list, is a table view, not a list view. So I could drag this on here, and we could lay out this list or table view and everything and use it. But actually, Apple gives us access to a thing called a table view controller, which is a view controller with a table view already in it, and a few other kind of nice things wired up. It makes it easy to do things like adding search filtering, pull to refresh, a bunch of different stuff. So I've got a table view controller, and that's where we're going to actually load all our data into the table view on it. Now if I look at the properties for this item here, I've got a class field. So I'm actually able to assign, by default it's this grayed out, it says UI table view controller, which is the default type for this. But I can say I want to actually make it a metals view controller. And this is going to go ahead and create for me a class called Metals View Controller. That's actually wired up to this storyboard view controller that I have. And this is really nice for creating your layouts, because I could come back into my view controller and I could say, you know what, let's put a button on here. We're going to get rid of that in a second. But I can take that button and I can say, let's name it Cool Button. And once I save that and go back into my class, if I didn't close it out, I can now reference this Cool button that's already been wired up for me. I could set the title of it to whatever text I want. So our designer works really well with the C# side of things, creating classes and everything. You can see here the generated designer code, so it's just automatically wiring stuff up for us. So it's a really easy way of working with your UI using storyboards. We do also support, there's an older way that Apple did it with Interface Builder, they call it. We support that as well. But this is kind of the nice new way to do it. So let's get rid of this button, show our table view again. We actually don't need to do anything more with this right now. We can go ahead and go to our code and start loading this table view. So the first thing that we would want to do is, just like on an activity, we want to know when that view controller has been created or has been loaded. So if I override the viewDidLoad method, this is Apple's method for us telling us that our view is loaded and we're ready to work with it. So this is where I could start working with my table view. Now it's nice in iOS, I don't actually have to wire up a reference to that table view. It's done for me. But kind of the same idea. There's no items property. There's no add. There's an add, but that's deceiving. It's actually a method on the UI view subclass or base class. So I need to do a similar thing here, and it's not an adapter, but here we call it a data source. And this data source needs to be a implement the interface IUI table view data source. You'll find on iOS that class names are really long, and that's partially because of the way Apple has named things. So I could do that. I could make a new class, metals source. Let's just make it short. I could implement the IUI table view source, or we already have a really nice class, base class to use, UI table view data source. How about I make that a class? And so we've already got a nice base class that we can go off of, and I can just implement this abstract class. And this is easier than Android was. It's only two methods that we need to implement. So the first one that I want to look at is this rows and section. So do you know on iOS how list views have, like, you can have headers and then items within those headers? So they have this concept built in of sections and then rows within each section. For our purposes, we're only going to use one section. We're not going to actually declare multiple sections. But I would need to provide the number of rows for each section that I would declare. So in this case, again, this sounds like we're going to want to have a list of a list of metal types, and you can start seeing here that this is getting a little bit repetitive, right? We've done something similar in Android already, and I'm just going to return the metals.count property. Let's import that using statement 2. Don't have the same issue yet. And so that one was pretty easy. But this one here, this is similar to our get view. This is get cell. We talk about these things as a cell, not a view for a table view in iOS, just different terminology. And they don't give us a recycled view to use, but they do have the same concept in iOS. Instead of passing it into this method, we need to actually ask the table view if we can dequeue a reusable cell. And when we ask it that, we need to provide it a string identifier. So this is how it figures out, this is how it assigns, recyclable table view cells. And we could have multiple types of table view cells that we might want to, one might have 3 labels, one might have an image on it, and we can recycle each type of those. We're going to get the right one based on the string identifier that we're using. So I'm just going to, it's arbitrary, you can use whatever you want for the string. I'm just going to use metal. So that's going to give me possibly a cell that's recycled, but the same thing as Android, it might not actually give me one, and there might not be any already left over to recycle. If that's the case, we have to create a new UI table view cell. We can use the default UI table view cell class here. We could subclass it and provide our own implementation and customize our own views within that cell, but we're going to use, just like we use the Android built-in one, we're going to use the iOS built-in one that has a subtitle, so a title and a subtitle to show the same data. And here we have to give it a reuse identifier. That's got a match here so that when this table view cell that we created is recycled, we can get it again by calling that dequeue reusable cell method. So now that we have a cell, we actually want to, well, we can return it. But before we do that, we want to assign our metal information. So let's go metal equals metals. You've seen this before. And this time, instead of, we don't have a position variable, we have this index path. And remember that we have the concept of sections and rows in each section. This index path gives us 2 properties. It gives us the section property, and then it gives us the row property. So it's up to us to pick the right row for a given section. Since we don't have multiple sections, we can just go straight to the row property. So we've got our metal now. We can say cell.title. Let's use IntelliSense here. Text label is the title. And we can say make the text be metal.name. And cell.detail_label.text equals, and we have that already made up here somewhere. I'm just going to copy and paste it. I don't really want to type that all out again. So we'll copy and paste that in and get our same type of data. So we're returning that cell. It's good to go. And again, we need to do some of the same things, though. We need to actually refresh that list, right? Because right now there's no metals in it. So let's copy and paste this method over here. And we'll go back into here, paste. This time we don't have that notify dataset changed method. It's not available to us, so let's just get rid of it. We still need to do something like that, but the method that we need to call to tell the table view that there's new data is not part of the data source class. It's part of the table view itself, so a little bit different. And then we need to actually, well, set up our adapter here. So let's, our source. And let's create a new instance of it here. Finally, we can set our table views data source to our source instance we created. And again, here we might be tempted to call the refresh method from our view did load, but again, that only gets called once per lifecycle of the view controller, just like on Android did for the activity. So let's do view did appear, which does exactly what it says. It'll get called every time this view controller is appearing, or has appeared, I should say. So let's say source.refresh async. We can await that. Oh man, I used the wrong shortcuts here on Windows always. I'm going to give you guys a seizure. And asyncify that. Again, watch out what you're doing here. And I think we are ready to go here. Now, this is where it's going to start getting cool. Let's first of all start our iOS project as the default project. You're going to see some things change around here up top. I want to select iPhone Simulator. And I'm selecting this, this is going to pull all of the different simulators I have installed on this Mac here. It's connected to this Mac here. So I'm going to use this iOS or iPhone 6s iOS 9.3, and we're just going to start this. Now, this is going to take another couple seconds again, so some cool things are going to happen. This is doing the building of like the .NET stuff on your Visual Studio, but then it's shipping things over and using this Mac as our build agent, which is doing the actual running through the Xcode toolchain and everything to create our actual application. Oh, build errors, what happened? This was going so well. Whoa, that's fun. Maybe my connection is giving me problems right now. Let's try it again. I really want to show this because one of the cool things that we announced recently, and it's actually still a preview install, I guess, that you have to set up, but we have this Visual Studio iOS simulator remote. So if this actually goes over to the Mac properly, it's going to open up a window on the Windows machine that will show you a view into the iOS simulator that's running on the Mac, that's running our app on the Mac. So here it's coming up. And the nice thing about this, I was saying how I love the touch screen in that Visor app I was doing for Android. Well, I can do touching on the screen here, and it'll translate into the simulator that's running on the Mac. So you'll see that all working very nicely. And it's kind of cool because there's no touch screen on a Mac. On Windows now, with the simulator remote, we can actually do things like pinch to zoom with our touch screen. So if we went into a map and did rotate and stuff like that, it all works. So this is, it's an addition onto Apple's own stuff that I think has made it a lot better. So here's our app. I didn't do a progress indicator. I didn't show you that this time, but we could go get a component. There's one that works almost identically. No. Oh, I didn't add the new, since I didn't add the NuVia package. All right, I know what I did here. Oh, and I did something else wrong too, so we'll fix that first. I gotta stop it first. So in my haste of adding the reference here, I didn't add the dependencies that reference needed, like newtonsoft.json. So let's just go ahead and add this. Oh, you know what I should do? I always forget, because this is one of the Achilles heels of Xamarin Studio, is we don't have a managed NuGet packages for the solution yet. I think that's coming, but I don't know where it is exactly yet. So let's do. Is it going to complain about 9.0.1? No, I don't think so. Let's install it here. Oh, we were so close. And then the last other thing that I forgot to do, remember when I said in the refresh async we can't call notify dataset change because it's different in iOS? We still need to do that, but in this case we'll come up to the view controller and tell the table view that to reload the data. And this is going to tell it that, hey, our table view source has changed. Go figure out what you need to do for the UI. All right, so let's build this again. Hope that it goes this time. This has already launched, I think. So while we're doing that, I'm going to show you some of the cool stuff on here. So I'm just touch screening it, load some maps. I can pinch to zoom. So this is all running right on. It's not even showing up on my Mac, which is kind of cool too. This is all running on my Mac. You can hit the home button, go back to it. But it's just cool that you don't actually have to leave your Windows PC if you're in Visual Studio. If you have things set up, you can do all your testing here. The other thing that I haven't. Question?
After we see the display, I've got a question.
Are you making sure it's going to work first? The other cool thing is I haven't played with it, but we do have this USB remoting tool too, where you could actually plug your iOS device, not just the simulator, your iOS device into your Windows machine, and it'll remote it over to your Mac. So if you have a Mac Mini in a closet somewhere, and then you can deploy to your iOS device that's plugged into your Windows machine as if it was on the Mac. So you're able to work completely on your Windows machine if you want. So this worked for us. I can scroll around here. It worked.
So I want you to repeat what you just basically been saying. Let's just say I'm a Windows developer. I've got a Windows machine. I want to develop an app like this that runs on Android, iOS, and how do I do this? I get on Mac.
Yeah. So your question is basically you want to make an app that runs on iOS and Android, maybe Windows as well, and you want to do it all in Visual Studio, right? Okay, so yeah. So yes, like I said, you need a Mac to do that, to do iOS apps. I'm sorry, but you need a Mac. Go get. No, you actually install you install Xamarin for your Mac, which would be like Xamarin Studio. You go to our website and you get the installer for the Mac. It'll put everything on that you need. Then you do have to go into your Mac settings, into your sharing settings, and set like remote login. So like you could SSH into your Mac. That has to be turned on. And then when that's all set up on your Mac, you put it in the closet, forget about it. Go to your Windows machine, install Xamarin within Visual, and open up Visual Studio, and then there's this.
You need Xcode too, or?
You need Xcode on your Mac, but our installer will take care of all that stuff for you. Then there's this Mac agent here, that you can choose what to connect to. So you can choose, set by IP address or whatever. Right now, this is what I'm connected to, my Mac here. So you connect to your Mac, it does all of the talking between the two, and it'll let you do the things like the iOS simulator remote. It'll ship everything over to build when it needs to on your Mac. It's like you don't really have to do much after that.
So I can then on my Windows development machine, I can call up the iOS emulator and the Android Windows phone all.
Yeah, and that's what we're doing now. This is the iOS simulator running on a Mac. It's basically like VNC'd into that specific application, right? And then your Android emulator and everything can run on Windows too. I like using, like I said, physical devices, and I use this Visor app to actually show what I'm looking at on the screen, and I can interact with the screen that way too. So yeah, you can do everything from Windows. And in fact, as much as it pains me to say it, because I love Xamarin Studio, I really do. I've kind of learned to like it. I used to love Visual Studio more. But I can't do Windows development on my Mac. So the only one true way to do development on all platforms is from your Windows machine. So that was our iOS app. It did the exact same thing there. Let's see, how are we doing anyway? You guys are just crushing it. Canada's modestly got a few golds and a few silvers, so we're not doing horribly for our population, I think. So that's the two apps there. What's that? Yeah, once we get into hockey, I mean, then we're fine. Question in the back. Like which version of OS 10? Are you asking like that? I don't know what our minimum version we support is. I think it's like 10.10 we're yeah, that's 10.10, right? I think. Yeah, Yosemite 10.10, I'm pretty sure. Does the Mac have to be super fast? No, not really. I mean, this is a pretty quick machine, but I do use my Mac Mini to do a bunch of stuff as well. That's kind of my typical build agent because I have it sitting in my office and I can just connect to it from wherever. Probably, if you were to go out and buy a new Mac today, you could probably get one of the lower spec Mac Minis, and that would suffice just fine. The different Android phones. How do you test the different Android phones? Well, I have about 15 of them in my office right now. Another topic, and I'd love to come back and even just speak on that. We have what we call our test cloud, which is a room in Denmark, or I think it's many rooms now, and we're up to, I think we're in the thousands of devices sitting, like physical devices that they have in the room, and you can go ahead and actually run. We call them UI tests. It's using NUnit, there's a few other ways you can do it, but the C# way is to use what we call UI tests. You write these NUnit tests, and you tell it to do things like click this button, take a picture of what it looks like, scroll down the list, make sure that a certain value is there, and you can run all of these tests in the cloud, and you can run them on all the different devices that we have. It's not free. I don't think it's necessarily cheap either. It is a pretty big effort to make something like that. And I don't know if it's available yet, but I know they announced at Evolve, our conference that we put on, that you can actually like remote specifically into one of the devices too. So if you're running your app and you're having problems and you just can't figure it out, you could actually get a hold of one device and debug right on that device remotely too, which is pretty cool. I'm really looking forward to using that. Yes.
There's no way to deploy the app to multiple emulators that are say, multiple physical devices connected to your computer?
You can't deploy to multiple ones like simultaneously, but you can definitely hook up multiple devices and choose. Like, so if I went to my list here, set this as my startup project. If I had multiple devices connected, this drop down here would show. I mean, it shows some of my emulators that aren't started up, the one that's not started up, but it would show everything here. So you can use Android Studios emulators, you can use Microsoft's Android emulator, Genymotion, and any physical device you connect. Anything that's in ADB, which is the Android debug bridge, anything that it recognizes, you can use. At the same time, multiple emulators, like you can have them running, but you can't you can't like debug on several of them at once. You have to pick the one you want to debug on at a given time. Yep. All right. I'm looking to somebody, one of the organizers. Do we want to take a break? I have some more that I'd love to. Okay, great. All right. So I want to show you a quick example in XAML with Xamarin Forms as well. Is everyone good for that? A little bit longer? Yeah. All right. Great. So I have, a quick. I'm just going to blow through some of the slide stuff just to give you an overview. I have a few slides that kind of outline Xamarin Forms a little bit better. So let's just do that quick. I promise I won't try and keep you too long. Oh, of course I started from the beginning. Good job. You know what? Let's not do it that way. All right. So Xamarin Forms, we talked about native apps, and having to do the UI-specific code on each platform, and that's great because you get a good experience, but Xamarin Forms is something that we started to try and take some of that pain away and write an abstraction for that portion of the UI. So this is our traditional approach, and this is how we view it with Xamarin Forms. You still have your shared backend code, but now we're adding this shared UI layer of code. And that's not to say that you can't still do the platform-specific stuff in addition with using Xamarin Forms. You can always drop down to platform-specific, but you have the option of starting out with this shared UI layer. And it should be very familiar to most of you. It's all XAML-based, or it can be XAML-based. You can do it through code too. We have a whole bunch of different pages and layouts and controls already pre-built for you. We do two-way data binding. So if you're familiar with how that works in XAML, for WPF, you'll feel right at home with all of this as well. We have a navigation service, so you can navigate between the pages easily, cross-platform, like that code can all live cross-platform. One of the things that's often overlooked is this animation API. You can write cross-platform code to do all sorts of animations. It's actually an abstraction over the platform-specific APIs that do animations, so it's really fast. So if you want to translate a box from here to here, it's going to go use I think core graphics on iOS, all of the native implementations, and you can do a lot of stuff with that and spruce up your app. We also give you a dependency service and a messaging center if you want to use them or bring your own. You're welcome to do that too. So mentioned a bunch of different pages. Your master detail, which is great for tablets, and it can adapt for a phone where you kind of pick your master and navigate to the detail. And then when you're on a tablet, a bigger screen, it'll show them side by side, that kind of thing. You can do all that. And then we have a bunch of different layouts. Some of them you'd be familiar with already if you know any WPF stuff, any of that kind of XAML. Our actual stack layout, your absolute, your grids, your scroll views, your frames. And then your layouts, you can have a whole bunch of different controls. Again, a lot of these probably look familiar. Your label, your button, your date picker, all that kind of stuff, an activity indicator. And then one of the other cool things, and this one's newer, is that you can actually embed custom native platform views now within your XAML views. So like in Android, a good example is you might want that floating action button that you see in Android sometimes. And you could do this before by creating your own custom renderer for your page on Android, but then you'd have to recreate a lot of the different UI elements if you're using your own renderer. Well, you can actually go ahead and take those native views now and inject them into your XAML views. So this is pretty powerful. I'm not going to get that far into it today, but Xamarin Forms keeps getting better and better. We have a lot of different partners that are making controls, all the ones you would expect, like Telerik, Infragistics. The big guys have come on board and are making control packages for this platform as well. So I mentioned it's XAML. It's not copy and paste XAML from your WPF app exactly, but if you know XAML already, you're going to feel very much at home. And here's some of the counterparts. We have a stack layout instead of a stack panel. And I don't know why they named some of these the way they did, but that's what we have right now. But it's pretty easy to adjust to. And similarly, we do data binding almost identically. We have a binding context instead of a data context. So here's some code. I don't know how easy it is to see, but that's basically creating the same type of layout from a shared set of XAML code, but it looks a little bit differently on every platform because this is an abstraction. It's not actually, we're not drawing all of these controls from from a drawing engine. We're not recreating them. These are actual Android buttons that you're seeing, actual iOS entry fields that you're seeing, actual tabs that you're seeing. we're abstracting over them so that you actually get that native look and feel on each platform from Xamarin Forms, even though you're writing the code once. Another thing that's really useful, and this isn't just for Xamarin Forms, but some of the plugins, and we call them plugins, they're NuGet packages. Some of them work in Xamarin Forms as well, but some of them work just fine in your native app. So there's a lot of times where you'll have your shared backend code, and you might want to do something like find your location coordinates, get your current location, right? Every platform has an API to do that. They're all a little bit different. Some of them have different capabilities within that, but sometimes you're just concerned about, hey, give me the coordinates I'm at. That's a good candidate to abstract away as well, right? Or to have the option to abstract away. There's nothing stopping you from going down to that platform-specific API and using the features that aren't in that abstraction. But we have a lot of cases now that we call plugins that are abstracting those things away. Things like, the battery, the GPS, your flash, getting pictures, stuff like that are all good candidates for this cross-platform abstraction layer. So we don't want to write specific code when we don't have to. And we want to keep as much of the code in that shared library as you can. And these plugins let us do that. So here's an example of a speech. So you want to do text-to-speech. Well, you want to call this method from your shared code, and you want the abstraction to take care of all the platform-specific stuff here, right? So AV speech synthesizer should be used on iOS. I shouldn't have to care how that happens. So you have a way of doing that with a bunch of different plugins. If that URL, github.com/Xamarin/plugins, James Montemagno, one of our evangelists, awesome guy, has made a slew of these, and for most of the common things that you're going to need to do. So doing simple things, you don't necessarily have to drop down to platform-specific code. Just check those out if you have something that you're trying to do. All right, I think I blew through that all right, so give me a few minutes to show you how to make a really simple XAML app here now. I'm going to do this in Xamarin Studio. I'm very comfortable in Xamarin Studio, as I think I alluded to well enough. So I'm just going to launch a new instance here, if it cooperates with me. There we go. Yeah.
Xamarin Studio is something you have to buy.
Xamarin Studio is, I don't even know what the licensing. I think it's free. It's all out there now. So Xamarin Studio is kind of like the Visual Studio equivalent on Mac, but we call it Xamarin Studio. So I'm going to create a new solution here. I'm going to create, instead of that single view, that native, one app for each platform, I'm going to create this Xamarin Forms app. And let's just call it Emotional Olympics, in the theme of Olympics. I want to take pictures of Olympians on podiums and figure out if they're happy or not, using Microsoft's, have you guys heard of Project Oxford? They have their cognitive services, a bunch of different APIs. So one of them is to find what the emotions are in a picture, so a face. So we're going to do that. I'm just going to go with the defaults here for where the solution goes. Oh, I have one already. Let's go 2. Let's cheat. I did this once before. I practiced, I promise. All right, so we're creating a new solution. We're going to end up with 3 projects. We're going to end up with the shared code project. This is where we're going to do most of our work with Xamarin Forms. We don't actually have to go into these other ones too much. We still have our Android project. We still have our iOS project. But if we look in our Android project now, instead of, let me just boost that up a bit. Is that good? You guys see that in the back? Perfect. Instead of doing a bunch of different work in this main activity, you can see here we're doing this Xamarin Forms init, and then we're saying, hey, load our application. And it's a new instance of this app class. Well, what's this app class? Let's go navigate to it. I used a shortcut here to navigate to the definition. I'm a little bit trigger happy with that on Xamarin Studio. So we have this app class here. This lives, if we look on the side here, this lives in our shared code base. And it inherits from a Xamarin Forms application. And what we're doing here is we're telling the app, oh, let's make a new instance of our main page, which is this Emotional Olympics 2 page. Really good name. Well, let's go to the definition of that page. Pretty simple. It's a content page. Here's the code behind for it. But since I chose, when I was creating, I glossed over it, I chose to do this app as a XAML app, it automatically created the XAML for me as well. This looks familiar, right? It's XAML. It's not anything too crazy. So let's start making this app do something interesting. I want to create 2 buttons, one to take a picture and one to pick a photo on my gallery if I already have a picture, and we want to analyze that picture. I want to show that picture. I want to show the happiness score, and I want to show the contempt score as well, because we can get that information too. So let's start making some XAML. So let's make a new stack layout. And inside our stack layout, actually, let's give it some padding, just to make it a little bit nicer looking. Let's make a button, and the text is going to be big. And let's make this one take a photo. And let's make another button called pick a photo. Let's make an image. Let's make, to actually show the photo we picked or took, right? Let's make a activity indicator to show that something's happening. I'm just going to put a placeholder here for us. Let's make it running right now. Let's add a label, and the text is going to be happiness score, and the font attributes, we're going to make it bold because it's going to be a title. Let's make another title called the contempt score, and let's make labels to hold the actual values we get back. All right, so pretty simple XAML. It's not too fancy. And now we actually want to start using this XAML. Well, one of the nice things about XAML is we get data binding, right? So we can create a view model and start binding our view model to this XAML page. So let's go ahead and make a new class, and let's just call it view model for short. It's a bad name, but that's okay. Let's start making some properties that we might want to data bind. So we want a command for the take photo command, right? Let's just add the, we have some ReSharper kind of like stuff, or Visual Studio kind of like stuff in Xamarin Studio. So it's not like this, you know, really bad way of working. I quite like it. Let's make a pick photo command. Let's tell if we're loading or not so we can bind the activity indicator. How about a happiness score? And what about a contempt score? And then we actually want to display that image too, so let's make an image source property. And let's import the using statement for this. All right, so I think that's most of our properties. Now the next thing that we're going to want to do is actually you know, bind these to our XAML, right? So let's come back here and we can do all of our data binding. You know, our command can be take photo command. And our pick photo command. Our image source is going to be our image property. This is going to be our loading property. And our text property will be our happiness. And finally, our contempt. All right. Looks good. We should be able to bind that to our view model now. Now we actually have to create our command handlers, right? So let's do pick photo command. I'm going to do this one first just to be quick. It's a new command. And in that command, we need to make a new, well, let's pass it a delegate. Let me learn about delegates today. So let's pass it a new delegate. And in here, we need to actually pick a photo. So how do we do that from our cross-platform specific code? Well, luckily, James Montemagno, my dear friend, has made a new plugin. It's called the Media plugin. And this lets us actually really, really easily get a photo either from the camera or from the image gallery. Now, he's popped up this README. We should probably read that and take heed of what we need to do. I'm not going to bother you with that right now. But now that we have that, we can go using plugin.media. We have this cross-media class that we've brought in. So let's get the current instance of it. Now let's say, let's pick a photo async. Pretty simple. That's asynchronous, so we could await that. So we probably want to asyncify things here a bit. And let's get that result. So we're going to get back a media file from this call, and this media file is going to give us a stream to that photo that we picked and also the path to where it's saved to. Once we have this, we want to actually send it off to the cognitive services and bring back the results. So let's pull in one more package, Project Oxford's Emotion API, pulling that down. When I get that down, I'm just going to go grab, I have an API key that you are not looking at, right? Nobody saw that. Nobody's going to see when I paste it in. Now that we've got that, we can do something here like a public async task, analyze. Let's pass in our media file. Let's create a new instance of our client. So Microsoft Project Oxford Emotion Services client. And here's that key that nobody's going to pay attention to. So I'm making a new instance of my client. This is a portable class library NuGet package I brought down. It works in my shared code layer. And all I need to do is say client.recognize async, another asynchronous call. And I can pass in the image URL, or I can pass in an image stream. And I know I have an image stream, so let's do that. It's going to be get stream. Let me just add my using statements here. Almost there. All right, so await analyze media file, call that up. We get a list. We'll get back in a list of emotions, an array of emotions. We're only concerned, we're going to show a picture of just one person, so we'll only ever have one emotion. So let's just get the first one. Ooh, that was not the helper I wanted. Let's do this. Did I? Oh yes, oh yeah, that's all sorts of wrong. And yes, I do need to await that. You're right. All right. System.link. All right, so we've got our emotion. Finally, we'll want to set all the different properties up, right? So, well, first of all, before we actually do that, we want to display the image. So let's set the image to be image source. And this time I'm going to say from file because I also have the file name from that media file we just grabbed. So I'll set that property. I'm going to set the happiness score to be the emotion. We'll see the emotion has a property scores. And in that score, I should have a happiness value. It's a float. Let's just make it into a percentage because we might get back some gnarly scientific notation values here if we don't do that. And then contempt is going to be the contempt property. And what am I missing here? I didn't do my loading yet. Let's do that. Loading equals true. And after we're done loading everything, loading equals false. Now, by default, this is just normal class. I don't have the iNotify property changed. To make this faster, I'm going to go, I forget what it's called explicitly. The Fody, has everyone worked with Fody? Has anyone not worked with Fody, I guess? Or, It's kind of a slick way to just inject some code for me. So I'm going to just do this property change.fody. Does everyone know what the iNotify property change interface is? Probably most of you have seen it. So it's just a way, it's when we're data binding, we generally use that interface. So we could say iNotify property change. And it's a way for us to, every time we change a value, to tell any subscribers to this view model that it's changed so they can go and update the UI for us. So we could do it the old-fashioned way, but that's a little bit more work. So I'm going to just do, I'm going to use Fody, which will just do that for me. Don't worry about this in particular. That's not the point of this. So let's just use that. I don't really want to implement that. It'll do it for me. The last thing I have to do, I have to add some configuration for Fody because it's not doing that in Xamarin Studio. All right. You didn't see that either. It's all just going to work. So this time, this way, anytime I set the property, it's going to trigger that iNotify property change event, which is what our XAML subscribes to in the binding, and then it knows, hey, I need to update the value or the UI for this value. So I didn't do anything with our take photo command. In the interest of time, I'm not going to. I think that should mostly do this. The last thing that we need to do is go back into our page here and actually create our view model. So let's just make a field for that. I kind of like to keep references to things around for garbage collection reasons. Make a new view model. And instead of setting the data context, we set the binding context of our page to be this view model. So that's what we're actually setting our source for the data binding. So I think that should do it. The last thing that I might have to do is add this media plugin package to this project as well. What we use a lot in Xamarin is this technique called bait and switch, which is a NuGet technique. So we might ship a portable class library that has stub implementations of a contract, and then we'll actually ship platform-specific implementations that implement that contract, that when you install the NuGet package to your iOS app, it's grabbing that platform-specific assembly, and when you're installing that same NuGet package into your PCL project, it's grabbing the stub implementation so that you can still compile, since that stub implementation is just the contract and it doesn't actually include platform-specific code. Hopefully that makes sense. All right, so I think I can run this now. Let's try it. I might have missed something. We'll see. So this is going to fire up my iOS simulator. I already have some pictures on the device. I'm not going to do it with the camera. Whoa, that's big. Let's scale that down. So here's my simulator. It compiled, so that's a good first sign. So here's my silly little layout. So I have my two buttons, right? My take or pick photo, my headers, and there's nothing else populated yet. So if I go to pick a photo, this is calling into that media plugin NuGet we downloaded. I didn't do any of this code. This is platform specific. I'm asking iOS via its photo APIs, how do I get a picture from your gallery? So I got two pictures here. I got someone that is really happy looking. So we just set our image here, and you saw the loading indicator, and Cognitive Services says, hey, in this picture, we saw someone with a face that was really happy. So a 99.96% happiness score, and not very contempt at all. I just picked these randomly. Don't read anything into this, but here's another picture that looks not so happy. Only 0.01% happy and very content. So, you know, this is all XAML. We did this really quickly. I think we got more accomplished in XAML and Xamarin Forms in a short time than we did with the native apps, and we certainly didn't have to do stuff, you know, twice, two slightly different ways. Do you want to quickly see if we can run this on this device, just to get a sense of what it looks like on Android? I don't know if I have pictures implemented on my gallery, but I can take a pic, or I can load a picture of it. Let's just see what the UI looks like. So to start a project, then I promise I'm done, and you can all go home. Well, I didn't implement. I can do that quickly too if you want to stay for 2 more minutes extra, but that's up to you guys. Because look at my view model code. I did the pick photo command, right? But I didn't do the take photo command. It'll take a second. So let's do the take photo command. And this one's a little bit more needy. I need to pass it in some options. This store camera media options. And for some reason, I don't know, James made this. He told me that it just has to be this way. So I'm going to listen to him because he's a smart guy. I have to specify the directory. It doesn't really matter what it is, and the name of where it's going to go. He said he's going to work on this and make this all have a default, but until he does, that's what we have to do. So that's all the extra code required to actually take a photo from the camera, and you'll see in a second here what that looks like. So let's start it up on Android. Go to this device. I'm going to go get my Visor app on here to show you the screen. Shouldn't take too long to deploy. It's pretty quick from a Mac. And so again, I mean, we didn't really touch those platform-specific projects, right? All we did was add some NuGet references to it. Yeah, I mean, you can drop down into them. It's a normal project. You can do whatever you need to do in it, but Xamarin Forms lets you abstract quite a bit away. Almost done. The first time you launch an Android app that you've built in debug mode on a device, it takes a bit longer because it installs a shared runtime when you're debugging, just to speed up future debug launches. So that's what you're seeing, an extra couple seconds here deploying. Let's just pull up this window. Who's going to volunteer to smile for the camera and not have too much contempt on their face? Yeah? Or I can get Rob up here. I can make Rob get up. Synchronizing assemblies, I promise we're almost done. Oh, you know what? Sorry?
Nobody else is doing what I'm doing.
Yeah? All right. I'm using the preview of NuGet here, so the first time I launch an app, for some reason it crashes always, but the second time it works. So you can see, well, I say the second time works and then it crashes. Thanks a lot. I think my connection's a bit loose here. You can see the layout looks very similar, right? As soon as it comes up, 2 buttons, but it's a bit different on Android because we're using the Android buttons instead of the iOS buttons. All right, let's take your picture. So you can see this is the Android camera app. I didn't have to do any special code. All right, let's see if that works. Let's see. This is really nerve-wracking here. Oh, don't tell me it's going to push everything down to where I can't see it. That's going to be sad. No, I didn't put it in a scroll view. Oh, man. Here's what we're going to do. We're going to cheat. We're going to cheat a little bit. Can I take a picture again? One more time?
Yeah, but get a little closer and then
Oh,
you'll be larger.
Yeah. I accidentally went. Oh, now I got it there. Go, come on. I accidentally went back into the pick a photo, and you could see that it's like an Android gallery this time, right? Which is kind of cool because again, I didn't do any platform-specific code. James did all that work for me in the plugin. Oh, come on. It's so painful when you're actually. Oh no, I did it again. Hold on. I promise. I think when I was testing, I always put the buttons in the reverse order. But you can't see it even. Take a photo. Take a photo. All right. Last time. All right. Let's hope this breakpoint works. All right, I hit my breakpoint, so I can see my happiness score was 0.98. Wow, that's pretty good. Pretty happy. That's sorry, that's not 0.98% because that hasn't been converted to a percent yet. So that's 98%. And scientific notation, not very contemptful. So I think that's a good pass. Very, very happy Olympian there. All right, that was a lot of coding. Thank you all for staying with me. Are there any questions before? If I was to pick a photo, I don't know if I saved it to the gallery. So yeah, I'm not sure. It might not be. You could do that though. You could invoke the API to do that. Yeah. Yeah, I mean, there are some things that you might like. The question was about device-specific stuff like the hamburger menu and stuff like that. You can drop down to the platform-specific UI level to do things like that. I don't think, unless there's like a third-party plugin that does it, there very well may be. I don't think you get that by default in Xamarin Forms, but that's the other thing. There's a lot of third-party libraries that have extra controls and stuff for Xamarin Forms out there. So you could certainly achieve it. It's just a matter of, I'm not sure how difficult in each specific case. Depends on if there's a control out there and how much work you want to put into it. But if I think you can still download it. If you download the Xamarin Evolve app from the either app store, that's all Xamarin Forms, and it looks perfect on each platform. Like, you would never know. And James did that one as well. Yes. Well, if I have a picture of multiple people, that actually might have returned multiple emotions. It'll pick up all the faces it can. That's Microsoft's the cognitive API that's doing that. So it should actually. I just grabbed the first one because I only wanted to find the one person in it. So it's probably going to grab the one that's at the forefront. Yes. To Gradle and so yeah, we have access to Android manifest. We don't use Gradle. So the question is, do we have access to Gradle, which is the build system you would use in like Android Studio for Java, or the Android manifest, which in this case, yeah, we do. We actually use this Android manifest just like you would in your Android app. So this again is something that Google's done. One of the interesting things is in Google and Android Studio, I don't know if they've made a helper for this yet, but you might have to go in here and say, I need to declare all the activities I've got in my code, and I need to say the classes, blah, blah, blah. Instead of us forcing you to do that, if you may have noticed in our activity, we had this attribute. You can mostly get attributes from your C# code to inject the equivalent into your Android manifest. It'll do that at build time for you. So that's a much nicer way. That way, all of your properties, about that manifest entry are set near where your code declaration is. So I think it's a better way of doing it.
My second question was, I know you first had pointed those APIs out.
Yeah.
So how long does it take the API?
Yeah. So I mean, the question was how long, until the new Android APIs are something you can consume. I think in the alpha channel we already have releases of it. So you can get that there. On iOS, we historically have a record of same-day support for the new iOS APIs for the latest iOS version. I think we'll still hit that with Android because Android 7 is still preview, right? So I would imagine, from what I understand, what's happening internally, we'll still hit that with Android. The honest truth of it is that iOS users upgrade so much faster. The adoption rate for a new iOS version is so much quicker than Android. I think like Android 4.4, after, was it 3 or 4 months, they only had like a 2% adoption rate or something like that. So, until our team grows more and more and more, the energy of getting that same day update is more on the iOS side than Android. But certainly, we're trying to get that as soon as we can too. Yep. Anyone else? It's more like, I mean, it's the API profiles. Like you'll select Xamarin Android as a platform you want to target in your portable class library, and that'll tell that assembly what base class libraries are available for that platform profile. So once you select all of those, it's like a matrix, basically, of APIs available and platforms that you selected, and that ends up being calculated into a profile number, and you can actually go look up what portable profiles exist. There's a whole slew of different numbers, and each number refers to a different combination of platforms that are supported in that profile. It depends on how the NuGet structured. So you're asking, in the portable class library, when you pull a NuGet down, which assembly gets referenced by that portable class library, and which assembly gets referenced by the iOS app, for instance. Yeah, the typical pattern, we call this the bait and switch trick. So go Google bait and switch, that'll give you a lot more information about it. Typically, we'll say, for the speech synthesizer, we'll have a speech synthesizer with a method called speak, and you pass it a string. In the PCL assembly that gets referenced, that implementation for a speech synthesizer class that implements that interface will have an empty method. It might throw an exception, it might do whatever. The point is that PCL implementation never gets called at runtime, because when you install the same NuGet package into an iOS app, we're actually we're shipping multiple assemblies, and you'll get the iOS specific one referenced in your iOS app, which actually contains implementation code, because that implementation code is what's calling AV speech synthesizer on iOS, because that's only available as an API on iOS. We probably have a pretty long conversation about it, but just look up bait and switch, and it'll give you a lot of information. Yeah, that's one technique. It doesn't have to happen that way. You can have implementation code in your portable class library. It's just that implementation code only has the APIs available to it for that portable profile. So I hope that helps. Anyone else before we take off? Yeah?
I have a couple questions. So the Xamarin forms, when you use that, is there any sort of slowdown or overhead
Yeah, I haven't worked a ton with Xamarin Forms, to be honest. I think there is some, there's always going to be some hit just because they have to do things even like, attribute lookups and stuff for different platform renders. There's always going to be a little bit of overhead there. I don't know if in practice it's something that people are finding to be a problem. I know there's been some debate over like performance of list views, and there's certain techniques you can do to make rendering of list like long list views and lots of items a lot faster in Xamarin Forms. But I couldn't tell you too much about the specifics. But I think the long and short of it is it's probably negligible.
And this is probably wishful thinking, but if you're using that, it doesn't get around the whole need a Mac, right?
No, yeah, it doesn't get around needing Mac. Again, like we interpret Apple's agreement that says every developer that's making iOS apps that's using Xcode needs to own their own Mac. I won't tell you officially that you can do it, but the build host, you might find that you could connect a few different computers to it if you tried. But we don't like officially support that. So you might be able to say, hey, two of you might be able to alternate using the same Mac build host, right, from your individual PCs. But that is totally off the record.
Well, thanks.
Can you mix native, like first part you showed with Xamarin Forms? Let's see that.
Yeah, so you can start with Xamarin Forms, and then you can drop down. One of the techniques we call it custom renderers. So for a given page, you could say on iOS, I want to create my own custom renderer and drop down to the iOS platform specific UI code to display that page's content, and that'll get used on iOS, but then you'll still use Xamarin Forms on the other platforms. So one of the nice things about that is you can create your whole app in Xamarin Forms, and you can pick and choose different spots on different platforms where you think you need to, do a little bit more tweaking to make it less platform generic, right? So you might have one screen that really needs a bit of work, but you can do that kind of at your own pace, and it doesn't have to be for all the platforms at once.
Is there any mobile backend as a service, like included authentication service on the server, or is this just for
Well, you can use like Azure to do like social authentication on the back end. So like Azure does that as a service. I think Google probably has something up that alley too. So we don't provide you with anything out of the box when you download Xamarin, but you can certainly Azure Mobile Services. They have a client SDK that works wonderfully with Xamarin, so you can use all of their stuff.
Does it have to be Azure or?
No, it doesn't have to be Azure. It could be any service you want. It's just a matter of, if I go to the Xamarin component store and I look up, different client libraries I want to use. So like if I go to Azure, Azure Mobile Client SDK is a really simple thing to add to my app, and then I can start using all of their different features like their social. They're getting started, guys. Isn't so good. Their social authentication, their easy tables, all that kind of stuff. So yeah, but certainly, I mean, anything you can do in .NET, like an HTTP client, you could do from Xamarin. Yeah.
You did one of your asynchronous calls
Yeah.
why is that again? Is that just
Well, long story short, the asynchronous call that when I overrode, the onResume method, I added async in front of the void declaration. I can't change that method from being a void, but if I don't return a task on a method that I'm using async in, I forgo capturing exceptions from those asynchronous calls within. So if that call failed and there was an exception, it wouldn't bubble up to me, and then that code would just die. That's just how async await works. So. No, that's not Xamarin specific. No. All right, I think I've tired you all out enough. So thank you all for coming out. I really appreciate you all being here and being so interested.